Okay guys, most likely this one will go smoother than the first video because with practice, even I get a little bit more better and proficient. So let's get started here. So, first thing we're going to do is make sure all our denominators are factored, right? That's already factored. This, I can do a GCF of 4 on it. Let me scribble that out since I have it factored now. So what is my common denominator? It's going to be the combination of all the pieces. You could have put the x minus 1 before the x plus 5. We generally like to keep our numbers first, however. So there's my common denominator. Okay, so as you can see, I'm timesing both of these expressions by that common denominator. Let's see what happens. Over here, notice the x minus 1 simplify, and all I'm left with is that. 4 times 4 is 16, x plus 5. This one has a plus, so that's cool. Don't have to worry about distributing a minus. Now let's look over here to the right expression. Notice the 4's cancel out, the x plus 5's cancel out, and I'm left with that times 3. So 3 times x minus 1. All right, so now it's a matter of doing some distributive property right here. So let's see, that's 16x. 16 times 5 is at 80, I'm pretty sure. I have a 3 I got to distribute, so that's another 3x. And a minus 3. All over 4, x plus 5, x minus 1. All right, let's do some simplifying. 16 and 3 is 19x. 80 minus 3 is a 77. All over 4, x plus 5, x minus 1. And I'm pretty sure, guys, 19 and 77 can't be simplified with a 4. So there's nothing to simplify. That should be our answer. All right, let's try another one. This one's a little different because we don't really have a fraction here. Technically, there is a 1 there, however, right? So, guys, this is my common denominator. X squared plus x minus 6. Now, let's follow our rules, though. Let's factor it. I was getting a little ahead of myself there. So we're going to do an x on it. I need a negative 6 with a plus 1 in the middle. So that means positive 3 times negative 2, right? 3 minus 2 is 1. 3 times negative 2 is negative 6. Perfect. So our common denominator is really x plus 3, x minus 2. Okay, so what's cool on the left expression right here, which I just circled in purple, is this again cancels out with that. And all I'm left with, because remember, this right here, guys, was x plus 3, x minus 2, correct? So they cancel each other out. All I'm left with is 6x plus 1. Now comes the sucky part. Over here, which I just looped in black, there is no denominator but 1 to simplify with. So I'm going to have to times all of that together. Nothing cancels out. So let's go ahead and do that. So let's go to a blank page, give us some more room to work with, right? Now, guys, the last video I went ahead and went in order like this. But if you want, you could times those two binomials together first. And since we have a lot of space, let's go ahead and use the area model. You don't have to use the area model. But for some of you, I know you prefer that. So notice x times x is x squared. Minus 2 times x is minus 2x. X times 3 is a 3x. And minus 2 times 3 is a minus 6. So what I really have right here is negative 5x times x squared. 3 minus 2 is 1x. And a minus 6. And let's go ahead and distribute the minus 5x now. Minus 5x cubed minus 5x squared plus 30x, because a negative times a negative there is a positive 30x. Okay, so going back to here, as you can see, I already wrote it in. And all we have to do is combine some like terms. So our denominator again is x plus 3, x minus 2. Let's put them in order by power. So negative 5x cubed would go first. Negative 5x squared would go second. I have a 30 and a 6, which makes 36x. And I have a plus 1. And I'm pretty sure, guys, you're not going to be able to factor or simplify this one. So there's our answer. All right. Guys. Oh, my gosh. Now, guys, let's factor this and see what happens. All right. This is about as evil as it gets, I think. So first thing I'm going to do is a GCF of 5a cubed. Notice they all divide by 5, and they all have an a3 in them. We're just doing a GCF for now. So I know that a squared times 5a3 is 5a5. I have a minus. I know 10a times 5a cubed is the 50a4. I see a plus. And finally, 25 times 5a cubed is 125a cubed. So I did a GCF of 5a3. Maybe you'll use your calculator to help you with the calculations. Now, guys, look right here. Do you think you can do an x and factor that further? Yes, you can. So let's do an x. I need a 25. I need a minus 10. So that's simply going to be negative 5 times negative 5, right? So here's what I have now, guys. I have 4a, or 4a over 1 if you like, plus I have a minus 5 over 5a3. Remember, I factored all of that right here, right? So I have a 5a3, and this part became a minus 5, a minus 5. Now, if you look at the second expression there, guys, can't I simplify it? Why don't we do this? Now that cancels out to 1. Okay? I'm just simplifying it, guys, before I do anything else. That was really the trick to make this one at least a little bit easier. Okay, so now what I really have is a 4a plus 1 over 5a cubed times just 1a minus 5. See, by doing that and that, guys, we're able to make it a little bit nicer. Now, guys, do you agree our common denominator is going to be this now? Remember, the denominator over here is just 1, right? So that's what we're going to be dealing with now. Okay, so our common denominator is going to be 5a3a minus 5. And we're going to times both of the expressions by that common denominator. Okay, so the sucky part, guys, is this time the left expression. I got to multiply all of that together. So you know what? I'm just going to do it down here if you don't mind. I have 5a cubed. You know what? I'm going to just go ahead and times it with 4a. So that actually gives me 20a4 times a minus 5, right? Let's go ahead and distribute that. That's 20a5 minus 100a4. So we have 20a to the 5 minus 100a to the 4. We have a plus. Now here comes the cool part, guys. When you look at the right expression, 5a plus 5a to the 3 cancels out, and a minus 5 cancels out. Only thing left there is the 1. So guys, there's basically my answer. I'm looking at it and I'm pretty sure you can't simplify that any further. Okay? Let's see if I have another one here. Aha. We'll have a couple more. All right. These actually, let's see what happens here, guys. So, see how this time there's nothing I have to factor. They're already factored, basically, right? So my common denominator is going to be x plus 5, x minus 4. Okay? So I'm going to times both expressions by that common denominator. Okay. So, the x plus 5s cancel out. And this is all I'm left with. Let's go ahead and distribute it. 6x squared minus 24x. I see a plus there, which is cool. Now let's look at our right expression. See how the x minus 4s cancel out. And the only thing I have left is 3x plus 15. Again, all I did was distribute right there. Okay? So we're almost done. We have 6x squared minus 21x plus 15 over x plus 5, x minus 4. And if I'm not mistaken, guys, I don't think there's anything we can simplify with the numerator and denominator there. So we're done. All right, let's do one more. Woo! Let's factor that, right? We could do a GCF of 4. All right. So now that I have it factored, do you agree my common denominator is going to be 4m plus 5? They both had an m plus 5. This one had a 4. So putting all the unique different pieces together, factors together, it's 4m plus 5. So I'm going to times both expressions by 4 times m plus 5, right? The common denominator. Okay. So if you look at my left expression right here, guys, the 4 and the m plus 5s cancel out. The only thing left is 2m. Let's be careful of that minus right there. On the right side, the m plus 5s cancel out. And the only thing I have left is 4 times 4, which is a 16. Now, guys, normally we would be done. But, guys, notice how all the numbers I can divide by 2. Let's divide by 2. That divided by 2 is 1m minus 16 divided by 2 is 8. 4 divided by 2 is 2 times with the m plus 5. Wow, guys. The only way to get good at these, again, is you got to practice them, all right? Even for me, it's good just to practice them myself again, just get proficient with them again. But that's basically how you add and subtract these rational expressions, guys. See you around.